Today's go-to training is going to be on day one of ALEKS. So it's going to cover all the stuff that you can expect to see in day one of ALEKS, which is going to be those first few slices of the pie. Now, what I want to do is I want to do an audio check to make sure that everyone can hear me. So if you can hear me, go ahead and type in the chat box yes. And if you can't, then obviously you won't be typing anything in because you can't hear me. Okay, so let's see. I'm going to do a little math here. Got 1, 2, 3, 4, 5 folks that type yes. And I've got 1, 2, 3, 4, 5, 6, 7 people here. Okay, so let's see who did not type yes. Okay, so let's see. We got Rebecca that did not type yes. Okay, so let's see if we can find Rebecca. Okay, so she just typed yes. Okay, so we're missing one person. Let's see, Jordan got Jordan. Daisy, yes. Edward, yes. Okay, so we got 7. Let's see, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Okay, so we got 7. And the 8th person is me, so I can hear myself. Okay, so once again, now that we made sure that there's not going to be any technical difficulties, I would like to welcome everyone to our first go-to training of this month. We're going to be covering day one of ALEKS. These are some of the concepts that you can expect to see in ALEKS. If you have any questions, type them in the chat box. When I'm finished talking, I will address your questions. The way my go-to trainings work and all the go-to trainings work a little different is I pretty much talk about a concept, then I'm going to ask some questions, or I'll give you guys an opportunity to solve a problem. Okay, and then we'll go over the answer. My go-to trainings are also recorded. This go-to training right now is being recorded. So what will happen is it will be archived in YouTube, and I will send everybody a copy of the link so that you'll get a chance to, if you want to watch the go-to training again, or to just kind of scan through it and pick up on concepts that you were having problems understanding when we were going over them live. Okay, so we're going to start. Okay, hopefully everyone can see my PowerPoint here. Okay, we're going to start with some basic math concepts. Okay, now, question might rise, why do we have to learn this stuff? Okay, why do we have to learn that whole numbers are from 0, 1, 2, 3, and 4? It kind of sounds elementary. Why do we have to learn that integers are -4, -3, all the negative numbers, 0, and all the positive numbers? Okay, 0 is neither positive or negative. It stands to itself. Why do we have to know that rational numbers are fractions? And if they are decimals, they terminate or stop. Why do we have to know what irrational numbers are? Okay, so that's probably a question that everybody's wondering, and a lot of people wonder about. And that's primarily because math is a language. Okay, and with a language, you communicate with other people. Okay, so when we say you're going to add two integers together, you got to know that we're talking about adding negative numbers, positive numbers, and zeros versus adding fractions. Okay, so when we're talking about the rules, that it takes to add integers, you'll know that we're talking about negative numbers, 0, and positive numbers. Okay, because the rules are going to be different for different types of numbers. So as we go along further in math, we might talk about, say, something called simplifying a rational expression. Okay, well, if you don't know what a rational number is, you're definitely not going to know what a rational expression is. Mathematicians speak the language of math. So when I talk, I'm going to talk math. Okay. So in order for you to understand me, you've got to be able to speak the language of math. You've got to know some math concepts or math words yourself. So when I say, okay, we're going to learn how to add integers, you've got to know what integers are. Okay, if I say, well, we're going to simplify rational numbers, you got to be able to know what rational numbers are. So that's why we start here. What a lot of students make the mistake of doing is they don't learn the language of math at all. What they try to do is just figure out how to solve the problems. You know, show me a few steps. I'll take those steps and then I'll solve the math problem. Okay. Well, that's like going to Russia and not being able to speak the language of Russia. Okay, well, maybe you can go there and buy a cup or something, but eventually somebody's going to ask you something, or you're going to need help with something, and you're going to have to be able to speak the language, because if you can't speak the language, you're not going to be able to communicate with the people. So that's why we start off with these very rudimentary concepts. Okay, so we start off with the real number system. Now, what is the real number system? The real number system is our entire number system uh, as we know it in arithmetic, okay, which is different than algebra. Real numbers can be put on a number line. So if you got a number line, if you can, like, say, draw a number line, uh, I don't want to do that. I don't want to end the training. Cancel. But let's say right here, if I'm going to go here and I'm going to draw a number line like this. Okay, so that's a number line. So any number that can be put on this number line, like 1/4 can be put on the number line. Okay, 0.75 can be put on the number line. Okay, the number 3 can be put on the number line. Over here we could put, say, -3. Okay, somewhere in here we could put -pi. Okay, so all these numbers can be put on the number line. So they're going to be called real numbers. Now, they're not all the same type of numbers. Okay, -3 is an integer. Okay, it's also um, a rational number as well. Okay, but it is an integer. Okay, 1/4 is a fraction. Okay, 3 happens to be a natural or counting number. It's also a whole number. It's also an integer, and it's also a rational number. Okay, and it's a real number. The numbers at the bottom, okay, are numbers that can fit into any of the set of numbers. Okay, pi is a irrational number. It goes on forever and ever and ever. And when I say a set of numbers, a set, when we talk about a set of numbers, like we say, well, we're going to talk about the set of natural numbers, which are like 1, 2, 3, 4, 5. Set of numbers is a well-defined collection of numbers. Okay, so when we say well-defined, we means that, every mathematician in the world knows that when I talk about natural numbers, what we're talking about. Okay, there's no ambiguity, no misunderstanding of what a well-defined collection. And we can call it a group too. I mean, it doesn't have to be called collection. We can call it a group, a well-defined collection of objects. They don't have to be numbers, but in this case, they are numbers. Well-defined collection of objects. Okay, so if we lined up 100 mathematicians and we said, what is an integer? All of them will be able to tell us what an integer is, and they would tell us, what belonged in the set and what didn't belong in the set. So that's what we talk about when we talk about sets. Okay, so when we talk about our real number system, or the set of real numbers, that's basically what we're talking about. But we need to have an understanding of these terms so that when you start seeing problems in ALEKS, you're going to know what you're talking about. When it says, okay, you're going to add integers, you're going to say, okay, well, Professor Clark talked about a rule for adding integers. And that rule is going to be different than adding rational numbers. Okay, so Well, let's move on a little bit further. Here's a breakdown. Okay, and we kind of touched on this a little bit. We said that all of our natural numbers, so all of these numbers here, all these numbers here and the natural numbers here also belong to the whole number set. They also belong to the integers, and they also are rational numbers. So in the set of natural numbers, the number 5 is in the set of natural numbers. But guess what? 5 is also a whole number. So 5 is also a whole number. And 5 is also an integer. Okay. And 5 is also a rational number. Okay. So 5 belongs to, all of these sets. And then 5 is also a real number. Now 5 is not an irrational number. Okay, we only have a few irrational numbers. Okay, perhaps the most famous irrational number is pi. Okay, and then we have other irrational numbers like e, which is Euler's number, and then we have like the square root of 2 and the square root of 3. These are all irrational numbers. Now they're irrational because they go on forever and ever and ever. They never stop and they don't repeat. So it's not like we're saying 0.666666666. That's repeating, so that's not a irrational number. That's rational. Okay, because we can just round that off to like, we can just put a repeating bar over it. Like say if we were looking like 0.666, we could just say 0.6 and put a repeating bar like that, and we know that that means 0.6666666. Okay, but these numbers below, they don't terminate or repeat. So when we say, well, okay, pi, because it doesn't repeat, we can't put an equal sign here. Okay, so what we do is we put an approximate sign that's like a wavy. It's still like an equal sign, but it's wavy. And then we say, well, it's approximated at 3.14. Okay. And so we do a lot of cool things with pi. Pi has been, counted up to the billionth place value. No, I say a trillion place value, I want to say. That's how far we've been able to count pi up to. We did find a set of numbers that, repeated for about 6 digits. And I think it was about like 5 or 6 nines that repeated. But you had to get like to the 2 or 300,000th place value to find that repeating of the nines. Okay, so pi, we approximated at 3.14. Okay, so that's kind of a back set of what we're looking at when we're working with uh, real numbers. Real numbers are composed of all of your rational numbers and all of your irrational numbers. Okay, and of course, all your integers, whole numbers, and natural numbers are also real numbers. Okay, so this part of understanding the numbers is giving us an ability to speak the language of math, which we're going to need, because ALEKS. Okay, does anybody know what ALEKS is, or has everybody seen ALEKS? Okay, yeah, so we got some folks that have seen ALEKS. Now, ALEKS, okay, is an artificial learning environment knowledge space system. Okay, that's what ALEKS is. Okay, so ALEKS's job is to test your math knowledge and then to help you build your math knowledge, you know, based upon what you know and what you need to know. Okay, ALEKS is going to speak the language of math, and ALEKS is going to force you to speak the language of math. So that's why when we start off with talking about math, we've got to start off with the language part of it. If you already know the language part of it, that's great. That means you're probably one of those people that are really good with math. If you don't know the language part of it, oh, I just made that private. I meant to send that to everybody. If you don't know the language, if you don't know if you don't know the language part of math, that means that you'll have an opportunity to brush up on it while you're in this class. Okay, so now we've kind of looked at the numbers. The numbers are one part of it. Okay, we've got the numbers. The numbers are like the nouns. Okay, it's like a person, place, or thing. That's what the numbers are. And then you've got like the symbols, which are like verbs and adverbs. Okay, because they're going to be doing things. Okay, like we've got like four basic operations. We've got addition, subtraction, multiplication, and division. So those are the four things that are going to be doing stuff. Okay, they're going to be doing things to the numbers. So like if we say 3 plus 5, okay, well what's happening at 3? It's being added to 5. So something's been done to it. Okay, so those four operations. Now those four operations depends on, the kind of numbers you're working with. Like say, what if that was like, those right there are natural numbers, but what if they were integers involved? Like -3 plus 5. Now, of course, with these two, we're just going to add them. Okay, but with these two right here, there's a rule that's different than the rule is for adding, counting the natural numbers. So now we got to know that rule for integers. Okay, because these are integers. Well, the rule for integers says if the signs are different, one's negative and one's positive, we subtract them. Okay, and so that's going to give us 2. And then the answer takes on the sign of the larger absolute value. So 5 is a larger digit than 3, therefore that's going to be a positive 2. Okay, so see how, we've got 3 and 5, but yet we did two totally different things with them, okay, based on the type of numbers that were involved. Even though we were being told to add, in one case we actually did add, in another case we had to subtract. Okay, well, that's what we're working with when we're understanding these symbols. So we're going to look at these symbols and get a better understanding of them because they're like verbs and adverbs and they're telling us what to do. Okay, so those are the basic operations: multiply, add, divide, and subtract. And really and truly, those are the only four things you do in math: multiply, divide, add, and subtract. Okay, now we're going to have some comparison symbols. We're only going to see 3 of them right here. We see equal, we see greater than, and we see less than. Okay, there are others. We've got like not equal, we have less than equal to, we got greater than equal to, and then you guys seen me do the wavy one, the approximation symbol. Okay, so that's an approximation symbol. So those are all comparison symbols. Those allow us to compare two things. Okay, even below, I'm comparing, two arithmetic expressions. I'm saying that 3 plus 5 is equal to 8. So I'm saying that they're the same thing. And so that's how I compare them. And then I'm saying -3 plus 5 is the same as 2. Okay, so I actually use the comparison symbol at the end once I perform the operations. So understanding the language, I know I got to know the nouns, the persons, the places, and the things, which are the natural numbers, the counting numbers, the integers, the rational numbers, the irrational numbers. And I also know I've got to know the verbs. Okay, the things that are telling me to do something. I've got to know the plus, the minus, the multiplication, the division, and I got to know the comparison symbols: equal, less than, greater than, less than, equal to, greater than, equal to, and approximate. Okay, and uh, understanding how those things relate will define the rule that I'll have to use to solve the problems. Okay, so when we put these two things together, we start to see that math is two things. Math is a language. In fact, we believe that math is the universal language. It is the original language. Okay, it's not a language that man had to create. It's one that we discovered. Okay, some people say that if aliens came from another world, the only language that we would be able to communicate with them with would be math. Okay, so that's part of it. Okay, let me clear this up for a second. Go back. Okay, now there's some things that we're going to have to know about these operations. Okay, because we're going to see them. Okay, we're going to have to recognize the symbols. and what they look like, and when they're going to show up in algebra problems, when they're going to show up in arithmetic problems. And then we're going to have to know those operations for when they're going to pop up in word problems. Because when they pop up in word problems, it's not going to say add and it's not going to say subtract. They're going to use other words, and we're going to have to know what those words mean. What we're going to be actually doing is translating the English to math. So we'll see a word problem, and we'll see a word, and we'll say, well, that word means to add. Or we'll see another word, and we'll say, well, wow, that word means to multiply. Okay, so we'll learn a few of those words now. And as we move further along in ALEKS, okay, probably around day 6 or 5, we'll learn more words that's going to help us to solve word problems. So if you're not good with word problems, okay, part of that reason is going to be because you can't identify those keywords to let you know whether you're going to multiply, subtract, or add. Okay, like when we look at multiplication down here, we see a word of. Now that means to multiply. Okay, when we work with percents much later on, not today, but much later on, we're going to see a word called off. And that word off is going to let us know that we're going to need to subtract before we multiply. Okay, so every time we see those words let us know automatically what we're supposed to do. Okay, we don't have to, second guess it or reason through it. The word tells you automatically, you multiply. What is 30% of 70? Okay, and I'm going to type that up here at the top here. It says, what is 30% of 70? Okay, so that's a question. Okay, now from this list down here, I automatically know what word tells me to multiply. I circled it. I see it. The word is of. So I know that I've got 30%, and the word of means to multiply, times 70. So now all I got to do is put 30% of 70, 30% times 7 in the calculator. Now, I tell you something else too. There are going to be other words in here that's going to give me a kick. See that equal sign right there? The word is means equal. And the word what means that it's a variable. So I'm going to call that x. That word what means that that's a variable. So what is a variable? So then when I finish that problem, I say, okay, 30% of 70 is 21. Okay, because 3 times 7 is 21. Okay, and so I know that 30% of this is 21. I'm using some things that I understand about numbers to find the answer without even doing any math. So that says when I do the multiplication here, that says 21. So 30% of 70 is 21. But that whole English phrase, that entire question started off with those key words. Okay, I'm not a rocket scientist. I just seen that word of, and I know that word of means multiply. Okay, I seen that word is, and that word is means equal. Okay, now if I didn't know that word of means multiply, now I got to think about this thing. Okay, and then I got to look at it and walk around it a little bit, and I may have to examine it for 30 or 40 minutes, and that's gobbling up a lot of time that I really don't have to be spending on math like that. Okay, so it kind of behooves me to learn these words so that when I see them in word problems, the word problems aren't as challenging or not as hard as they should be. Okay, now with the addition and subtraction, you see how those operations, they're just one of them. You don't even have to, addition is addition, subtraction, subtraction. But I want to show you guys something else, and I'm going to pull this back for a second. Then I'm going to go back to it. Look at here with the multiplication. Look how many ways we can show multiplication. Okay, you can put two letters right next to each other. So when you have AB, that really means A times B. Okay, we can use the asterisk. Okay, that dot is called the center dot. Okay, now I want to show you something with that center dot. Okay, this right here, when the dot is right in the center like this, that means 3 times 4. Okay, which is the answer is 12. Okay, this right here means when the dot's at the bottom down here, that's a decimal. Okay, that's not a center dot. That's a decimal. So that means 3.4. Okay. Sometimes parentheses will let us know that we're supposed to multiply. Okay, so let's say, for instance, we have something like 7 here, and then we got a 5 like that, and they're both in parentheses. So that's telling us that we should multiply. So that's going to be 35. Okay. Now, we have to make sure that we don't confuse that parenthesis with the grouping symbol parenthesis. Okay, this one means to multiply. Okay, the grouping symbol, when the parenthesis becomes a grouping symbol, is when we have a group. Okay, for instance, here's a group: 7 plus 5. Okay, a group is 2 or more things. Okay, so we got a group here. Okay, so that's a group. This is a group. So that's what that is. So that's when we talk about order of operation, we talk about PEMDAS. That is the parenthesis. Okay. When we're talking about this right here, okay, that is not parentheses. This is multiplication. Okay. And the best way to remember it, a group is 2 or more things. Okay, so if you don't have 2 or more things in there, it's gonna be multiplication. Okay, so right here, this is multiplication. It's not PEMDAS. It's not the parentheses from PEMDAS because it's only one. One person is not a group. That's an individual. Okay, so that's one of the things that you're gonna have to commit to memory. Probably want to write it down in your notes. If I see one thing in the parentheses, it's not parentheses, it's multiplication. If I see 2 or 3 things in the parentheses, then that's not uh, multiplication, that's a group. So therefore, that's parentheses. Okay, so now you see that X right there, that multiplication symbol? We don't use that in algebra. Okay, so what's going to happen when we start this class? You're going to see that X at the beginning when we're working with the arithmetic. Because we work with arithmetic, we work with financial math, we work with algebra, we work with geometry, we work with probability, and we work with statistics in this class. So when we are working with arithmetic, we're going to see that symbol. But when we work with algebra, we're not going to see it. Does anybody know why we won't be seeing that multiplication symbol? I'm talking about this one right here when we're working with algebra. Yes, that's correct, Edward, because it will be used as a variable in some equations. Yep, you guys are definitely correct, Rebecca. It can be confused with the variable x. So that's why we don't use it. Okay, because it can be confused with the variable x. Okay, now here's division. Okay, we've got a few ways to divide, and this is not the only ways to divide because we've got something that you'll see if you get to much more advanced algebra called synthetic division. So there are a few ways to divide. Okay, we got that short division. Okay, so this one right here is short division. Then we got long division right here. Okay, and then we've got the fraction bar. So, a fraction is a division problem waiting to happen. Sometimes we divide and sometimes we don't. Okay, so that's important to note. Okay, uh, speaking of division, does anyone know the steps to long division? Does anyone know the steps? And there are 4 steps. There are 4 steps to long division. Okay, John, thanks. That's an honest answer. Okay, so there are 4 steps to long division. Okay. Okay, so let's look at them then. Okay, so it's been time since we've seen it, so we'll look at it. I'm going to pull this back. I'm going to write the steps. I'm going to type the steps in, but then I also want to show you. I also want to show you how to work them because that's going to be important. When we convert fractions to decimals, we're going to have to use these steps for long division. When we're converting from one unit of measurement to another unit of measurement, we're going to have to use these steps, okay? Because you can't always put a decimal there. Sometimes you have to put feet and inches and not 3.75 feet. So we've got to know the steps for long division. Okay, so here go the steps. Okay, number 1 is going to be to divide. Number 2, let me move over. Number 2 is going to be to multiply. Okay, number 3 is going to be to subtract. And number 4 is going to be to bring down. Okay, so those are the steps. And then we keep repeating the steps until there is no more math to be done. Okay, and so those are the steps. So you want to write those 4 steps down. Okay, we're going to divide, then we're going to multiply, then we're going to subtract, and then we're going to bring down. Okay, math is composed of algorithms. Okay, and that's going to be the second thing that we're going to understand about math. Okay, one, math is a language. We said it's a universal language. We said that if aliens came from another world, the only language we could communicate with them in would be mathematics. But math is also the study of patterns, and patterns have processes. Okay, steps that have to be remembered and have to be repeated. Okay, so this is going to be the first step that we're going to come across in our basic operations is with long division. It's got 4 steps: divide, multiply, subtract, and bring down. Okay, so I'm going to put these steps right here on the side: divide, multiply, subtract, and bring down. Okay, so my first step is to divide. So I'm going to take 7 and I'm going to say, can I put 7 into 2? Nope. So then I'm going to take 7 and see if I can put it into 29. I'm going to take the 2 numbers and bring them together. Can I put 7, 20? Yeah, I can take some 7s out of 29. Okay, now the way I can do it is I can say, okay, how many 7s can I take out? Okay, so I can say 7 here. Okay, and there's a quicker way of doing it. I'm just showing you the longer way right now. So I don't want anybody to think I don't know the quicker way, because I do. I'm just seeing how many I can take out. Okay, 15, 7, 8, 7, 1. Okay, so let's see how many times I did that. I took 1 out. I took 2 out. I took 3 out. And I took 4 out. So I took 4 of them out. Okay, so how many I took out, I'm going to put it right here. Okay, that's that first step right there to divide. So I divided. Okay, and I was able to take 4 out. Okay, right here, 1, 2, 3, 4. So I was able to take 4 of them out. Now from here, my next step is going to be to multiply. Okay, so what I'm going to multiply is the 7 times 4. 7 times 4. The 1 on the side and the 1 on the top is going to give me 28. Okay, so that's going to give me 28. Okay, so that's the multiplication. And then my next step is going to be to subtract. So 29 minus 28 is going to give me 1. Of course, and I knew that from the subtraction that I was doing every time I was taking 7 out. Okay. Now my next step after I finish subtracting, I'm just going to take that off. Then I'm going to bring down the 4. Okay. So I brought down the 4. Okay. So now I've finished with that part of the process. But guess what? I still got more math to do. So that means I got to start all over again. So I'm going to put, another D, another M, another S, and another B. And I'm just putting this here to remind me of what the 4 steps are. Okay, because if I know the rules, I can do the math. If I don't know the rules, it doesn't matter, how much education I have. I have a master's in mathematics, but that doesn't matter if I don't know the rules. Okay, so I got to know the rules. So I'm writing the rules down on the side to help me to remember. So next thing I'm going to do is I'm going to look at 7 and see how many 7s I can take out of 14 down here at the bottom. Okay, because I took right here underneath the division sign, and now I'm going to come here underneath the division sign. And so when I say, well, how many 7s can I take out of 14? I can go to my 7 time charts. Okay, and this is different from the subtraction that I did. I'm just showing you the shortcut now. Okay, and I'm going to stop at 3. I'm not going to put the whole timetable chart here because I don't need it. That's 21. I don't know why I'm getting ready to put a 3 there. Okay. So when I look at the timetable charts, I know I can't take 3 out because 7 times 3 is 21. I can take 1 out, but I'm still going to have a lot left over. So the closest amount I can take out, because that's 14, is I see it right here. If I take out 14, I can take out 2, and then that means that's going to give me 14. So I can use multiplication to work division because 7 times 2 is 14, but 14 divided by 2 is 7. So they share the same numbers. So from here, I'm going to say, okay, I can take 2 of them out. And then that's going to give me 7 times 2 here. That's going to give me 14. Okay, so I'm going to divide, and then, of course, 7 times 2 is 14. That means I multiplied. When I said 7 times 2 is 14. Then when I subtract, I got 0. Okay. Then my next step is to bring down to 5. Like that. Okay. And then I start that process all over again. How many 7s can I take out of 5? Well, I now know that, I can't take out, I know I can't take out any 7s out of 5 because 5 is a smaller number. So I'm going to put a 0 here. And then I'm going to multiply 7 times 0, which is going to be 0. And then I'm going to subtract. Okay. Now, if I bring down any numbers from here, I'm going to have to drop here a decimal because there's no numbers back there. And so once I start creating or pulling numbers to bring down that don't exist, then I got to put a decimal and put a 0. Or I can just leave it at that. I can just say my answer is 420 with a remainder of 5. Okay. Now, when we're converting, we'll want to leave it like this because, that could be 420 meters, 420 pounds, and 5, fractions of whatever else we use besides pounds. But that could be 420 feet with 5 inches or something. Okay, so we don't have to make it a decimal. But if we were going to make it a decimal, once we put that 0, we can drop as many zeros here. And then bring the next one down, and then that becomes 50. And then, of course, we can take 7 times, and then we got to put a decimal here at that point. And then now we've got 7 times 7 is 49. Okay, and so then we just keep going on until we can get this closed out, or if we want to round to the nearest hundredth place. Okay, but the most important thing is the steps for long division, or divide, multiply, subtract, bring down. If you know those steps, you can perform long division, which is going to be a very important skill that we're going to see as we move forward. Okay, so we're going to talk a little bit more about the operations. Okay, once again, we're learning the language of math. We're starting at the very beginning. Okay, because as you know, some of you guys stated you haven't seen math in quite some time, and so it's going to be really beneficial to see this stuff from the beginning instead of jumping all over the place. Okay, so when we look at addition, okay, we add numbers together, and addition. Okay, so numbers that are added are called constant terms. Okay, or if we subtract them, they are called constant terms. Okay, and they're constant terms like numbers like 4, 5, 6, and 7. They don't have any variables to them. Okay, the answer is going to be the sum. Okay, so we had a number like, let's say we had like 7 plus 5 equals 12. Okay, 7 and 5 are constant terms, and 12 is the sum. Now, we had something like x plus 3 equals 8. 8 is the sum, 3 is a constant term, and x is a variable. Okay. Addition is commutative. Does anybody know what that word commutative means? What does that word commutative mean? All right, communicate, that's close. That's close. That's close. Commutative. It's got a T in it, commutative. Okay, so what do you guys think that seems like? Okay, Edward, thank you. That's an honest answer. So you see that word commutative. What do you think that word comes from? Commutative. Commutative. Commute. That's correct, John. It comes from commute. And the word commute means to move around or to go back and forward. Okay, so inside the word commutative is the word commute. Right here, commute. Okay, so inside that word commutative is the word commute. Okay, a word is always composed of a root or a base word, and then sometimes it has a prefix or a suffix, like say the word run. Run is a base or a root word, and then on top of that I can put rerun. So I can put that word rerun there. Rerun is, the re is a prefix. And of course the run is a root or a base word. So the root or base word for commutative is commute, which means that we can move the numbers around. You know, changing the order of the numbers will not change the outcome or the answer. Okay, so that's the importance of the commutative property. And then reordering can sometimes help you solve the problem faster, but it can also sometimes just help you solve the problem if it's algebra. Okay, so here are numbers, and we can see we've used the commutative property. And the reason why we can see we've used the commutative property, look at the 5 and the 2 here. Okay, and we'll put an arrow here so we can see that they've been switched around. And then look at the 5 and the 2 here. See how they've been moved around? Okay, so with the commutative property, you know, switching around the 5 and the 2, we still come up with 15. Okay, but you know, 10 plus 5 is a whole lot easier to add than 13 plus 2. You know, not a lot, but it is. All right, some more understanding of our basic operations. Subtraction is the reverse of addition. Okay, so that means they got the same uh, concepts involved. So let's say we could say 3 plus 4 is 7. And then we can go 7 minus 4 is 3. Okay, so see how they both have a 7 in them? They both have a 3 in them. And they both have 4s in them. Okay, so the numbers have just been rearranged. Okay, so there's a relationship between subtraction and addition. Okay, normally when you're working with addition and you need to solve a problem with addition and it's challenging, you can use subtraction to help you out. We do it all the time when we're working with equations. Okay, so the answer to a subtraction problem is called the difference. Okay, so like with this problem right here, uh, the, uh, the difference of 7 and 4 is 3. Okay, subtraction is not commutative. Okay, moving the numbers around will get you in trouble. Cannot move those numbers around. It'll create problems. Multiplication. Okay, multiplication is a short form of addition. Okay, it's a quicker way to get to addition. And it is the opposite of division. So multiplication is a faster addition process. So instead of saying 7 plus 7 plus 7, we can simply say 3 times 7. And of course, we can see when we go 7 times 2, why it's so much important to use the multiplication as opposed to the addition. Okay, multiplying any number by 0 results in 0. And that's going to be important. Learn everything you can about 0 because 0 is one of those special numbers in math. It's got a lot of properties to it. Okay, a lot of people don't realize how important 0 is. I mean, 0 is such a important part of math. Just understanding 0 helps out with a lot of stuff in math. Okay, and so, here's some work with 0. Okay, 0. Okay. With multiplication also, the answer to multiplication is the product. So we say, the product of 7 and 5, it means to multiply. Product of 7 and 5 is 35. Multiplication, like addition, is commutative. If multiplication is a shortcut for addition, it would stand to reason that multiplication and addition has the same properties or the same powers. Okay, the order does not matter. Reordering, it helps us to solve algebra problems, and it helps us to solve problems faster as well. Okay, these are the different ways that we can express multiplication. We looked at this earlier. Okay, really important. Okay, because we're not going to always use the same way every time. And, we just want to make sure that we're able to understand what's being asked of us. Because it's frustrating when you know the answer, but you didn't understand the question. And so now you're getting it wrong because you didn't know that, the 2 and the 3 next to each other over here they were really wanting you to multiply. And that answer is really 6 and not 23. Okay, so that's why we really got to make sure that we understand these symbols and what they mean. And same way here. Like, I'll see a problem like this and a student will say, well, that's a decimal. That's 2.3. But see where that dot is? That dot is in the middle. It's not at the bottom. Okay, so when that dot is in the middle like that, that means multiplication. And it's really frustrating when you think that, you're working with a decimal and you're not. You're working with two whole numbers and you're being asked to multiply them. So that's why it's so important to be able to recognize the different ways that we multiply, because it's not just one way. It's a lot of different ways, and we're not gonna, do it the same way all the time. You're just not, because different countries, different, institutions, different programs. Even in ALEKS, you'll see it 3 or 4 different ways. You're not gonna see it the same way all the time. So that's got to resonate with you. Okay, you can even go back, look back through this recording. Write it down. Make sure you understand that multiplication. There are a lot of different symbols for multiplying, and I need to know all of them. Okay, now multiplication has factors. Okay, and this is going to be the first place we're going to see this word factor. We're going to see this word factor plenty other times. So when we say 3 times 4 equals 12. Okay, so 3 is a factor. Okay, not that good, but I think you guys got an idea of what I mean. And 4 is a factor too. Okay, and then we got 12. 12 is going to be the product. Okay, because we said the answer to a multiplication problem is the product. Okay, so so now that word factor, we really want to hang on to that word, because later on we're going to see something like this right here, 7 over 21, and they're going to ask us to simplify this. And the way we're going to simplify it is by finding the largest factor. Okay, and then that's going to be 7 there. That's going to be 7 there. And then I'm going to show you how I came up with these factors. It's going to be 1 over 3. Okay, so what I'm going to do is I'm going to look for ways I can come up with 7. 1 times 7 equals 7. Ways I can come up with 21. 1 times 21 equals 21. And 3 times 7 equals 21. Okay, and so needless to say, these are all factors because these are numbers that we're multiplying together. So that's what makes them factors. Okay, so when I look at ways I can come up with 7, I see a factor right there. And I see the same factor right here. So that means that both of these can be divided by 7. Now, that 7 is going to be called what we call the GCF, or the greatest common factor. Okay, and it all starts right here. It all starts in multiplication. That's where we first get introduced to this concept of factors. Okay, and then of course we see it further when we're working with other concepts like quadratic functions, okay, and polynomials. Greatest common factor. Okay, so the GCF, the greatest common factor. Okay, so that's how it comes about. Okay, but it starts here with this term factor. Now, one of the things I like to do is when we're working with a concept, sometimes I kind of like to, take a glimpse into the future and show you where that concept is taking you, because all this stuff is tied together. Okay, and if you don't get it here, you're going to have a whole lot of problems when it becomes more complicated and more bigger later on. That's why, like, if people have problems like day 1, day 2, by the time they got day 5, day 6, they're freaking out. Okay, because that concept of 7 times 8 equals 56, and we tell you to list the factors of 56, and we say, well, okay, well, a factor is 7. Another factor is 8, because if you can multiply them together, then they're factors, and they're going to come up with 56. and then we got a product of 56. Right here, it's not that complicated. Okay, but when you start working with fractions, it becomes a little challenging. And when you start working with like quadratic functions, it becomes really challenging. Okay, but if we can master it here, by the time we get there, we'll have a better handle on it. Okay, so that's why that term factors is so important, because we're going to be using it later on with fractions. So when people say, oh, I hate fractions, okay, fractions deal with multiplication and division. Okay, and if you can understand those concepts and understand how they connect and interact, then when you get to fractions are going to be real easy for you. So I'm going to clean that, go back, so I get rid of my writing. Okay. Now numbers that cannot be factored are prime numbers. Okay, so numbers that cannot be factored, or they only have two factors, like one in itself, those are prime numbers. Okay, and I want to talk about prime numbers for a second. Okay, these are all prime numbers here. Okay, now watch this right here. If you put two prime numbers together on a fraction, like let's say you put 17 over 23. Okay, because both of those numbers are prime numbers, guess what happens? This can't be simplified. Okay, so you don't have to worry about simplifying this fraction because they're both prime numbers. So anytime you got two prime numbers together like that, they can't be simplified. Okay, now look at something else down here. 2 is an even number. It is the only even number that is a prime number. Okay, so it is the only even number that's prime. Okay, another thing you're going to see is the number 1. Okay, 1 is not a prime number, and it's not a composite number either. 1 is a unit. 1 is a unit. Okay, and the reason why, and I'm going to put the definition of a prime number and the definition of a composite number in our chat box. Okay, so a composite number is a number that has 3 or more factors. So that's what a composite number is. It's got 3 or more factors. Like take the number, see the number 9 is not down here. We got 5 and 7. 9 is a composite number because we can say 1 times 9, and we can say 3 times 3. Okay. So 9 has 3 factors. Okay, so the factors of 9 are 1, 3, and 9. Okay, so 9 has 3 factors, 1, 3, and 9. So that makes it a composite number. Okay, and then so I'll say therefore 9 is a composite number because it has 3 or more factors. Okay, 3 or more, that's the key word. Okay, prime numbers only have 2 factors. Okay, they only have 2 factors. So if we took the number 2, you could only come up with 2 by multiplying 1 times 2. Or if we took the number 11, you could only come up with 11 by multiplying 1 times 11. Okay, so the factors of 11 are only 1 and 11. Okay, so the factors of 11 are 1 and 11. Therefore, 11 is a prime number. Okay, now the number 1 only has 1 factor, 1. So we look at the number 1, 1 times 1 equals 1. Okay, so we say the factors 1 is 1. Okay. Now, here goes the kick. Okay, I'm going to put it all on the same thing. Composite numbers have 3 or more factors. Prime numbers have only 2 factors, because 1 does not have 2 factors, nor 3 or more factors. It is neither prime or composite. 1 is a unit because it does not meet the definition of a composite or prime number. Okay, so that's why we say 1 is a unit. 1 is not a prime number. So that's an important concept. So when we look at, prime numbers and composite numbers and how they work, then we start to see that. Now, that concept of prime and composite numbers is going to play a key role when we're working with fractions. So the more you understand prime and composite numbers, you'll understand fractions. For instance, I'm going to show you one more thing, and then we're going to scoot on to other things. Okay, so I'm going to put a number up here. Watch this right here. 16 and 20. Okay. 16 and 20 are both composite numbers. I know they're composite numbers because I know the factors of 16. 1 times 16 is 16, 2 times 8 is 16, and 4 times 4 is 16. That's more than 3 factors. I know 20 is a composite number. 1 times 20 is 20, 2 times 10 is 20, and 4 times 5 is 20. That's more than 3 factors. So both of those numbers are composites. Okay, and I know they're composites also because every even number is a composite number except for 2. So, I look at this fraction, I say, well, this fraction can probably be simplified, because they're not both prime numbers. I don't see prime numbers anywhere. Now, I know when I came across 4 times 4, and I know when I came across 4 times 5, they gave me 16 and 20. So therefore, both of these numbers can be divided by 4. Okay, and so that's the importance of understanding prime numbers and composite numbers. It just helps you to work with fractions even better. The language part of this is very important. And then of course I can see right here 4 times 4 is 16, and 4 times 5 here is 20. So I can work it backwards and use multiplication to verify the division that I did, because there's a relationship between the two. All right, so we're going to go to division. Now, we just showed you that, division and multiplication have a relationship. Okay. And the answer in a division is called the quotient. Okay, a fraction is also a division problem, and an average is also a division problem. Okay, so if you got, let's say you got 3 grades. Let me go back, because I want to look at an average. Let's say you got 100, and you put in an 80. Well, we'll give you a 70. So those are your grades. Okay, so this is going to be a division problem because you're going to have to add up all of these. Then that's going to give you 270. And then you'll divide them by 3 because there's 3 numbers there. And then that's going to give you a 90. Okay, so that's going to be your average. It's a 90. That's an A. Even though you had 170, which is a D, your grade is still a 90 in the class. Let's look at another one with the average thing. Because let's say we're going to do 100 on the first one, 100 on the second one, and then once we make that second 100, we say, oh man, I can take it easy in this class. I'm not going to even do the next assignment because I made 200s. My average is 100. So I'm going to do a 0 on this one. And then when I add those together, that's going to give me 200. Then I got to take 200 and divide it by 3. I'm going to have to use long division to do this one because it's not going to go in evenly. So I'm going to use those 4 steps for long division. Does anybody remember what those 4 steps for long division are? What are those 4 steps for long division? That is correct. Divide, multiply, subtract, and bring down. Okay, so those are the 4 steps. Divide, multiply, subtract, and bring down. Okay, so we're going to divide first. How many 3's can we take out of 20? We know we can't take out 7 because 7 times 3 is 21. So we can't take 7 out. Okay, because 7 times 3 is 21. And 21 is bigger than 20. So we're going to take out the next number, which will be 6. Okay, so we divided 20 by 3, and we were able to take out 6 3's. And then we're going to multiply. 6 times 3 is going to give us 18. And then our next step is to subtract. It's going to give us 2. Then we're going to bring down. That's going to give us 20. Then we're going to do this process all over again. We're going to divide. It's going to give us 6. Then we're going to multiply 18. Okay, and then we're noticing that this thing is going to keep repeating at this point. I'm going to put a decimal here. Pull a decimal up here because I want my decimals to line up. And then I'm going to put zeros here. I can put 2. And then I'm going to bring that 0 down. Now the reason why I put that decimal there is because I had to throw in another 0. Now that's 20 again. And so at this point, I'm starting to see that no matter how many times I'm doing this, I'm winding up with 20 and 18. Okay, so it's repeating. So what I do, I'm going to just put another 6 here and put a bar over it because it's repeating. I know it's repeating. Now at this point, that grade is now a 66, which is an F. I'm no longer passing the class. Okay, so I use division to figure out my average. Okay, now, I'm a teacher, so I did this on purpose because, I want students to understand how important it is to do your assignments. Okay, you can't take zeros. Okay, you got to do your work. Even if, let's say the person decided, let's say they decided that they were going to do 100. A 100 here, and let's see, they were going to do, say, let's say let's put in a 50 for them. They made a 50 on the assignment. Well, yeah, we'll give them a 40. It really wasn't a great assignment. They did a 40. That's going to give them 240. Then we're going to take 240. Now, mind you, they did a 40. They didn't do like a 40 is like a really, it's not a great F. It's not like they did a 55 or 60. They did a 40. And then we're going to take 240 divided by 3. And so we'll use long division over it. Okay. Now, 24 divided by 3 is going to give you 8. 8 times 3 is 24. We're going to bring this down, and that's going to be 0. We're going to drag another 0 down here. At 0, 3 divided by 0 is 0. So look at that. They got an 80 as a grade. Okay. Now the 80 is not as good as the 90 because they got when they got the 70, but it's a whole lot better than the 66 here. So here they got an F average because they came up with a 0. When they made a 70, they got an A average. And that person who made the 40, guess what their average is? A B. Okay. Uh, this is an example of how we use math to make, better decisions. Math takes all the feelings out of the process. So even if I don't think I'm going to do that well on assignment, guess what? I'm going to do it anyway. Okay, because I know if I do the assignment, that the math is telling me I'm going to have a better grade point average than if I don't do it. And then on the next assignment, I'll boomerang and make an A on it, like I did on the assignments before. Okay. There's an inverse relationship between multiplication and division. We can see it. 6 times 2 is 12. We can also say 12 divided by 2 is 6. So that's what we mean when we mean inverse relationship, that they'll offset each other. 12 divided by 2. Like that is 6. Okay, they got the same numbers involved. Okay. Okay, more about division. See all the ways we can do division? Okay, we got a ton of ways we can do division. Okay, all these ways are important. This way is real important because you got to convert things. You're going to use long division for that. That way is important. And then these two ways are really important because they work with fractions. You're going to work with fractions in math. Okay, and so that's going to be important. And sometimes we got to know that when we're working with fractions and we simplify a fraction, like 63 over 9 can be simplified down to 7 simply by dividing. And then also, if we wanted to convert a fraction to a decimal, we would have to divide for that. Okay, now there is a rule for division, and this is a very important rule. Division by 0 is not allowed. Okay, I'm gonna put that in the chat box area too, because I want everybody to understand that. Division by 0 is not allowed. It is forbidden. Okay, so if we've got 9 divided by 0, and you can put this in your calculator, your answer is going to be undefined. And sometimes the calculator just say it's an error. The calculator say that's an error. You're not supposed to be doing this. Division by 0 is undefined. Okay, and that A means any number. A stands for any. So any number divided by 0 is going to be undefined. Now you can divide 0 by a number. So 0 divided by 5, like say if we had, which is different because the numbers are in different places. And remember we said that division is not commutative, so you can't be moving stuff around. That's going to be 0. Okay. But you can't divide by 0, but 0 can be divided. Okay, so we see the difference. Now, if you have a question about it, just put in your calculator because the calculator will tell you that's an error. Can't do it. You can put it in both ways. One way you'll come up with 0, the other way you'll come up with an error. Okay, so here are the rules to adding and multiplication. Remember we said that addition and multiplication are similar. Multiplication is a shortcut for addition. So they're going to share that rule of the commutative property. That means the order matters. You can move the numbers around and come up with the same answer. Okay, with addition and multiplication. Now the associative property has that word associate in it. So that word associate means groups. Associate talks about groups. The groups you belong to. the groups you hang out with. And so the associative property talks about the parentheses, how they move around. Okay. So when we look here, look at this right here. The A, B, C are in the same place. Okay, the only thing that changed were the parentheses. See where the parentheses are? In the first one, they're up front. On the other side equal sign, they're on the back. Okay, so with the associative property, we're talking about changing the groups. Okay, but the numbers are all in the same place. Let's see, we got 4, 4, 3, 3, 2, and 2. All the numbers are in the same place. The numbers have not moved. So if the numbers don't move, you can't call it commutative because they didn't move. It's like, I will commute to work. Okay, if I stay home, I did not commute because I haven't moved. Okay, so it's the same thing. Okay, so the associative property is going to be a property for multiplication and addition. Okay. And then we have the distributive property. The root word of the distributive is to distribute. So here we're going to have distribute. And the word distribute means to hand out, not hang out, but hand out. Okay, so if I distribute back the test, I give them back to everybody. So what's being distributed here? The A. And in this case, it's the multiplication of A. Well, thank you, Jared. So it's the multiplication of A. Okay, now remember we said that we got to be able to recognize the different ways multiplication shows up. Okay, so this is one of those ways. And we can always go back, and we seen this at the beginning because we had a problem in the multiplication section that says the multiplication of A like this times the multiplication of B like that. Okay, well we can see that right there when we've got A and then the multiplication of that to B and C like that. So what we're going to say is A times B and then A times C. Okay, so and this is one of those key reasons and ways we've got to be able to recognize multiplication when we see it. Okay. I want to go back. So the distributive property says we're going to multiply whatever is on the outside by everything on the inside. So we're going to say A times B plus A times C. Okay, and then that's how we'll get our answer. The distributive property, when we look at distributive property, you're going to learn to love this property because the distributive property causes the parentheses to disappear. The distributive property causes the parentheses to disappear or release. Okay, so that's what the distributive property does. It causes the parentheses to disappear or release. And then the next property we have is the identity property. Okay, the identity property states that anytime we add something to 0, it's going to give us that number. So anything added to 0 is automatically that number. So if we say 0 plus a triangle, the answer is going to be a triangle. Okay, and that's the only time you can add and definitively know what your answer is without thinking. Anytime you're adding by 0. That's going to be one of those special properties of 0 that we'll see. Okay, remember when I said that, learn as much as you can about 0, because 0 has a lot of wonderful properties that, it's going to help your math knowledge out. I mean, it's really, an extraordinary number. The identity number for multiplication is going to be 1. Anytime you multiply something by 1, it'll give you that number. Now, you can't use 0 for multiplication because we have a saying about 0, and it's a math joke, and we just say 0 is a serial killer. Anything multiplied by 0 is 0. So if we say like 34 times 15 times 18 times, I'm gonna put it in 18 times 12 times 2,346 times 0, that whole answer is going to equal 0. Okay, so 0 will kill a whole bunch of numbers when you're multiplying. So that's why we can't use 0 as an identity number. Okay, if we wanted to, identify 34, we would have to say 34 times 1. And then that would identify the answer as 34. Or if we say y times 1, I'm going to use the asterisk in this case, times 1, that's going to be y. Okay, but you can't use 0 for a multiplication. You can use 0 for addition now. We can say, y plus 0 equals y. So you can use 0 as the identity number for addition, but it's not the identity number for multiplication. So we want to be really careful when we're looking at these properties. Now, I'm going to give you, my take on the properties. The properties for algebra, geometry, and other advanced fields of math are like flashlights that help you to work in the dark. Okay? You don't need them as much with arithmetic. So you don't need them as much with arithmetic. But when you get to algebra and geometry and probability and statistics and financial math, you're going to need those properties. Okay? We'll use the distributive property, to solve equations. Okay, we're going to use the distributive property, the identity property, the associative and the commutative property when we're working with formulas. So when we're working with advanced fields of math, we need these properties. These properties allow us to work in the dark like a flashlight. We shine it and we can see everything and understand what we need to be able to do in a problem. Okay. In arithmetic, you don't need it. Okay, so we're not going to do this one because I typically show that video in the classroom. Okay, let's do this right here. Well, we got about 24 minutes. We can muster through it. Okay, so we've got place value. Okay, now place value is important because I want to give you a basic definition for addition. Addition is the combining of two or more groups of the same objects. So you can only add things that are like you can add tens to tens, you can add hundreds to hundreds, you can add thousands to thousands. So you got to know what place value something's in order for you to add it. Let's say, for instance, if we had numbers like this, 1,238 plus 15. Okay. In this case, you can't add the 2 and 5 together because they're in different places. They have different values. In order for you to add them together, they have to be alike. So, we know that this is the ones, that this is the tens, and this is the hundreds. I probably should have just used the numbers above them and been done with it. Because now I'm trying to write out these words very small. So we've got hundreds, hundreds, tens and ones. So we can only add the ones together. We can only add the tens together, like that. Okay, and we can only have one digit in each place value, which brings us to carrying and borrowing. So we got 8 plus 5 is 13. But you can't put 13 because that's two digits. That's a 1 and a 3. So the 1 has to be carried. So we'll put it up here. And then we got 3 plus 1 plus the 1 makes 4. Okay. And then we just bring down the 2 and we just bring down the 1. So that's our answer. Carrying, let me type that in. Carrying and borrowing are important concepts when working with place values. If you need more help with that, a good website is purplemath.com, and I'm gonna put it in here for you. Okay, so things you need to brush up on that we're not covering, like maybe carrying and borrowing, you can look at that in purplemath.com. Okay, so our system works on powers of 10. Our system is called the Dewey Decimal Number System. Okay, so the system is the Dewey Decimal Number System. Number system, okay. Decimal is the same as 10. Okay, so anytime we say the word decimal, we mean 10. Okay, so and I want to show you something what I mean by that, okay? So let's say we got 34.7, and we multiply that by 10. Really what we're saying is, because that's 10 and decimal mean the same thing, we're really saying that we're working with the decimal. So in this answer, we don't really even have to multiply. We just simply move the decimal one place like that, and our answer becomes 34. Well, I'm sorry, we don't move it one place that way. I don't know, I was thinking. You move it one place this way. And so our answer becomes 347. Okay. So decimal is the same as 10. So whenever we're working with a base of 10, we simply have to move the decimal. To the right if we're multiplying, and to the left if we're dividing. Okay. Let me put up another one of those in case I created some confusion. And then we'll put a 10 here. Now we're going to multiply. And so what that means is that if we're going to multiply by 10, one base of 10, we're going to increase or move the decimal by one base. So we're multiplying by 1, so we move it 1. So it's going to be 7.43. Now, what if we were multiplying by something like, say, 0.284, and we're going to multiply that by 1,000? Okay. Now, 1,000 is 3 bases of 10. It is 3 bases of 10 because we got 3 zeros. That's what makes it 3 bases. 1 0 makes it 1 base. Okay. Another way we can express that is 10 to the third power. Okay. And that means that there are 3 zeros. 10 to the first power means that you've got 10, which is 1 0. Okay, so we got 1,000 here. Okay, so now instead of just multiplying by 1,000, because we've got 3 zeros, we can move the decimal 3 places. And so that answer is 284. Okay, so that's what I mean when we say our number system is the Dewey Decimal Number System and is based on units of 10. So decimal and 10 mean the same thing. And that's why when we start talking about the metric system in a few days, you're going to find that the metric system is based on units of 10 as well. And it's also based upon decimals, not fractions, because decimal and 10 mean the same thing. And the metric system is based upon a base or power of 10, which means it's based on decimals. Okay, so as we move down this, we look at the numbers. Now, our place value chart is systematized. I mean, it's really systematized. Okay, it's broken down into units. Okay, each unit has ones, tens, and hundreds. So the decimal. Okay, so the place value chart. The place value chart is broken down into units. And I'm going to talk about those units in a second, broken down into units. And each unit has 3 place values. 3 place values, which are ones, tens, and hundreds. Okay, so when we look at it, this is what we're looking at. Okay, so my first unit is going to be called the ones units. Okay, let me push it up here. So that first unit right there is the ones unit. Okay, that's what it's called. This is the ones unit. Okay, and notice with that ones unit, we've got ones, tens, and hundreds. Okay, so and a unit is 3 digits. Okay, so we got the ones unit. The next 3 digits are going to be called the thousands unit. Okay, and identifying the units is important for reading the number. Thousands unit. Next one is going to be called the millions. Unit. And then this last one right here is going to be called billions. And they just keep going up. Each time they keep going up. The next one, if we had another set, it would be called trillions. And so they just keep going up. Okay. Now, each one of these units have ones, tens, and hundreds in it. Okay, so let's say we wanted to read the millions unit. Let's say we wanted to read this unit right here. We're going to read that as 378 million. Okay, we're going to read the numbers and then we're going to state the unit, 378 million. And let's say we wanted to read the thousands unit. Then we're going to say, well, that's 378,912,000. And then, of course, if we want to read a ones unit, we don't have to say the word ones. We just get to say 43. But one thing that we're not going to do as we're reading these numbers, we're never going to use the word and, because the word and is the number that we use to reference a decimal. Okay, so you can't use the word and. You know, you may want to take a breath because that's a really big number and say the word and, because sometimes we like to use the word and a lot. Okay, as we're going through things, but you can't. Okay, so here when we look at this part right here, I want to look at this whole thing. We're going to say 146,378,912,043. That's the number. We don't say and 43, we say 43. Okay. And when we look at the place value chart, we notice we've got ones, tens, hundreds. Okay, here we've got 1,000, 10,000, 100,000. I want to circle that so you can see that. Okay, so we got ones, tens, hundreds. Here we've got 1,000s, 10,000, 100,000s. Here we've got 1 million, 10 million, 100 million. And then we've got 1 billion, 10 billion, 100 billion. Now, you notice with the thousands, millions, and the billions, even though that was 1, you can't see the number 1. 1 is invisible a lot in math. Okay, so this is the first place we're getting a chance to see that. So moving forward, just stick that in your notes. I'm going to put that on the side because that's so critical to what we're going to see later on in algebra. One is a number that is invisible a lot in math. Okay, so 1 is a number that's invisible a lot in math. So instead of saying, hand me the 1 paper, we just say, hand me the paper. And it's understood that it's 1. So 1 is going to be invisible a lot. Okay, but we look at place value charts. Place value charts are broken down into units. Each unit has 3 digits. It has ones, tens, and hundreds in each unit. Okay, so when we read a number, we read the number, then we state the unit. The number is 146. What unit is it? It's billions, 146 billion. We've got 378. What unit? Millions. We've got 912. What units? Thousands. Okay, so that's how we read numbers when we're looking at the place value. It's important to understand that when we're adding, numbers are placed in the correct place value because our basic definition of addition says we can only add things that are alike. Okay, that's that old saying, old cliche. We can only compare apples to apples and oranges to oranges. You can't add things that are not alike. Okay, so when we've heard that a lot in the world. You can't add apples and oranges. Okay, they got to be alike for you to add them. Okay, so when we're reading numbers, we kind of talked about it. So here, what we're going to do is we're going to separate these with the commas, and then we're going to look at the place values. Okay, so we look at the units here. Okay, we know that these are the ones. I'm just going to put the number 1. We know that these are the thousands, so I'm going to put the number 30 because it'll save me on my writing. And then this one right here is a million, so I'm just about to put a mil here. Okay, so when we read this, we know we're going to read it 32,841,796. So that's the way it gets read. We read the number, then we state the place value. Okay. Okay, so there we go. Okay, so the next concept we want to look at is rounding. Okay, rounding is a very important concept in math. Okay, does anybody know the rule for rounding? What is the rule for rounding? Okay, round down with 1 and 4, round up from 5 to 9. or greater than 5, you round up. Okay, so if it's 5 or greater, you round up. Okay, so excellent. You guys know the rule. Okay, yep. So if it's 1 to 4, it goes, the whole number goes down, the digit stays the same. Okay, and I want to look at that and reference it because it depends on how you're looking at it, whether it's going to round down or whether it's going to stay the same. So let's take, say, 3, 8, 4. Now, when we round to the nearest 10 place, okay, so it depends on how you're looking at this, the digit is going to stay the same that's in the tens place. Okay, so the digit will stay the same, but the number is gonna go down. Okay, so it's a play on words, so we just have to make sure that we get that part of it. And it doesn't matter how you state it, as long as you understand that that's what you're working with and you're comfortable with the verbiage. Okay, because at the end of the day, you're gonna have to be the one to work with it. Okay, so as Edward said, when it's between 1 and 4, okay, or even 0, if it's 4 or less, we're gonna round down. Okay, so that is 4 or less. Now, so what's rounding down? The number is rounding down. Okay, because we went from 384 to 380. That number went down. Okay, but the digit 8 stayed the same. So if we say, well, if it's 4 or less, the digit will stay the same. Okay, or we can say if it's 4 or less, we're going to round the number down. Okay, so it depends on the verbiage, but it's the same thing. Okay, let's say we have 386 and we're rounding to the nearest 10 place. Okay, a lot of times they're going to tell you what place to round to, so make sure you pay attention to that part of it. You're going to come up with a different answer depending on what place they tell you to round to. Okay, so we're going to look at we got the 10th place here, so we're going to circle the 6 because that's going to determine whether we're going to round up or down when we're talking about the number, or whether the digit's going to stay the same or go up if we're talking about the place value. Okay, so this case 8, okay, 6 is 5 or higher, so the 8's going to go up. Okay, so when you're rounding up, the digit and the number goes up. Okay, so here we went to 390. Okay, but Edward and Stephen did a good job of providing us with responses. I think Stephen's response was private, so you guys couldn't see it, but I could. Okay, so let's look at it. All right, so that's the rule right there. Edward and Stephen did a good job of providing it to us. If you're talking about 4 or less, and we're talking about 0 to 4, okay, we're going to leave the digit the same. Okay, or we're going to round the number down. And we talked about the difference between leaving the digit the same and rounding the number down. We even provided an example of that. For the second part of that, if the number to the right of the digit that we're rounding is 5 or higher, or we say 5 to 9, we're going to round the digit up. And we can also say you're going to round the number up, because rounding the digit up and rounding the number up are going to be the same thing. Okay, so that's the rule. Okay, now why do you guys think we round? Why do you guys think we round? Well, what is the purpose behind rounding? Okay, to achieve a whole number, that is definitely one of the reasons. To give accurate approximations. Boy, you guys are on top of it. For certain numbers, yep. Okay, so we got two wonderful answers. A lot of times we're round to achieve a whole number. If you're working, say for instance, you're in a restaurant and you want to give a tip or something, you'll round it to a whole number, just so that you can make the math easier. And then we're also looking for accurate approximations for certain numbers. And then some other reasons are time, just because it's just faster. Okay. And then another reason is we'll round just to see what the answer should or could be before we get started. So let's say, for instance, we got something like this right here. Let me go back here. Okay, we can move. Let's say we got something like this right here. 7, and we're going to divide 28.43. Okay, so we got to divide this number. Well, I don't know what it is. Not right now without doing the math, but I can round it. I can say, well, you know what? What I'm going to do is I'm going to say 28 divided by 7. I'm going to round that 28.43 to 7. And then when I divide, I now know my answer got to be around 4. Okay, so, like Stephen said, to achieve whole numbers, and once I got those whole numbers, I now know that answer's got to be around 4. I'm going to actually go ahead and figure out what the correct answer is using the long steps for division. But I got a framework for what my answer should be. And, like Edward said, I've got an accurate approximation, okay, which was quick and fast, okay, because it took me a matter of seconds to figure out that my answer needed to be around 4. And when I go into this problem, I'm going to go into this problem with much more confidence because I kind of know what my answer should be. I know I shouldn't be coming up with 40 or 40 cent. I know it should be around $4 and something. So I'm going to start off with 7 divided by 28. That's going to give me 4. I'm going to line my decimal up here. 7 times 4 is 28 here. I'm going to subtract 0, bring down the 4. Okay. At that point, how many can I pull out? I can pull out 0 there. Okay, so that I got to subtract again. 0 minus that's going to give me 4. Drag down the 3. Okay, 7 times 6 is 42. Subtract with the 1. I can keep dragging down zeros all day, guys. That's going to be 1 there. And then I'm going to 7 times 1 is 7 here. All right. And then I'm going to quit right here because I'm not going to keep doing this problem. I'm going to take that 4.061 like that. And I'm going to pretend like this is a money problem. So since it's a money problem, I just need to round to the nearest penny. Okay. That 1 is 4 less. So that answer is going to go, the number is going to go down to 4.06. The digit is going to stay the same. So that's going to be my final answer, $4.06. Okay. So sometimes you'll round for your answer too, especially if you're working with a concept that works in the real world, like money. You'll round to the nearest hundredth place. Okay, because that's the hundredth place that we work with. Okay. But $4.06 is real close to my answer of $4. Okay. So that's the benefit of rounding. Okay, so here's a number right here. We're going to round it to the nearest hundredth place. We'll look at the number behind the hundredth place, which is going to be the 6. And then we'll see if it's 5 or higher. If it is, we go up. And so here we see that the answer went up to 900. Okay, so this is the number that this is the number that's in the hundredth place right there. We're not going to do that video. All right, so here's a problem for you. Well, let me take that back. Here's a problem for you guys to do. And then we're going to call it a day. I'll stick around for questions because it's 11:50. So this is going to be a problem that I'm going to let you guys do. We're going to use estimating and rounding to do this problem, and then we're going to call it a day. Okay, so you got to estimate this first by rounding. So let's see what you guys are going to come up with. Okay, so let's see. Edward has 2,900. Okay, so that's normal. Jordan has the same answer. Okay, so we came up with 2,900 for the most part. Okay, I think Martha said that if we're going to actually do the real number, it's going to be 3,000. Okay, so we're rounding to the nearest hundred place. Okay, so these are the numbers that we're working with right here, going up or staying the same. If we're talking about the digits, we're talking about the numbers, we're talking about going up or down. Okay, so these are the numbers that we're working with. Okay, so everything after these numbers should be zeros. Okay, so let's look at it. Okay, so we're gonna round 1,587. The 5 goes up to 6 because 8 is 5 or higher. With the 930, the 9 stays the same because the 3 is 4 or less. And then, of course, the 4 stays the same in the 400 because the 0 is 4 or less. So that gives us 2,900 for our answer. Okay, so that's our estimated or rounded answer. Okay, so that's going to be a wrap for the day. It's 11:53. Okay, now what I'm going to do is I'm going to archive this video, and then you can go back to the video and um, watch it if you want to. If you don't need to watch it, it's there for you. All right, and I want to wish you guys a great day. I'm going to stick around for these last like 7 minutes and field questions about assignments. If you don't have any questions about assignments, you're free to go. And you guys are welcome. And thanks for being a great group. An overview of assignment one. Sure, let me pull it up right quick. Assignment one. What's the assignment one is a project assignment. Okay. Okay, it's a project assignment. What you're going to be asked to do is you're going to be asked to create an overlay. Okay, so you're going to be asked to create like, um, what do they call it? A blueprint. Okay, now the blueprint I think is only worth about 10% of the grade. So, spend time on it, but not a lot of time. Uh, there are applications out there that you can use to um, create blueprints. I'm trying to see if I can find one for you. And then I'm going to put it in here for you. And you can use this to create your own blueprint with it because they don't want the blueprints being hand drawn. Okay, let's see. Here we go. Okay, so this is the application you can use for that assignment. Uh, it's a really good one. It'll let you put your blueprint together. Uh, see this page. A good thing to do, and we'll actually have a go-to training on this particular assignment. Um, let's see, not this week, but definitely next week. Uh, you'll be asked to do conversions, okay, like to increase, a measurement by 24%, decrease it by 2/3. There's like a, let me pull it up. Why is it not coming up? Okay, now that's not the part I want to see. There, I want to see this part. I'm gonna pull it up and show it to you. Okay. All right. Can you see my screen? Okay. So this is something you'll be asked to do. You'll be asked to fill in like all these boxes. Like they'll want you to increase 18 feet by 24 feet. Okay. And then they'll want you to increase 5.49 meters by 24 percent. Okay. Now, notice one of the things that they're going to say with your customary up here, they're going to want the feet and they're going to want it to be converted to feet and inches. Okay. You know what? I just highlighted that and it did something customary, feet and inches. Here we go. We turn it off. Turn it all off. Okay. So here's the part I'm trying to get to show you where it's going to say it needs to go to feet and inches. There we go. Okay, so that part right there says it must be in feet and inches and rounded to the nearest inch. Okay, so that's something that you're going to have to watch out for. Okay, then the next step is going to tell you to decrease it by 1/3. Okay, then when you go down here, it's going to ask you to do calculate areas. Okay, here in this box, you got to read these directions and follow them carefully. I just changed them to red for you. So you're going to read it. You're going to have to subtract out the doors, take out the windows when necessary. And they'll tell you when you got doors and windows. Like when you look at this first one here, I'm going to change it to red. See how that says one door on this wall? And then right underneath it, it's going to say one window on this wall. So you can see that part of it. So you're going to go in and you're going to complete all that. Okay. When we have the go to training on assignment 1, we're going to talk about the square footage and how you use the right units of measurement, and then you'll have these 5 questions down here to do. Okay, but this one spreadsheet pretty much is going to be the gist of that assignment. Okay, and then you'll answer these 5 questions, and then this is how you do your blueprint stuff right here. Okay, I gave you a website already for it, so you can use the website to do your 2D blueprint. Okay, I'm gonna put don't save there because I'm not gonna do that. One place that you really want to go is to the rubric, because the rubric is going to tell you how much everything's worth. See, the blueprint is only worth like 9 points. That's all that blueprint's worth is 9. 36 points is in the dimensions. 30 points are in the surface area, and 25 points are in the budget analysis. So let's say you just blow up on the blueprint. You don't do a great job on it. Okay. Even if you don't get any points on blueprints, you can still pick up a 91. Okay. So you want to spend time on the blueprint because you want those 9 points, because those 9 points can drop you a letter grade if you're not perfect. Okay. But you don't want to spend all your time for those 9 points. Okay. So I would recommend looking at the rubric, which I just pulled up, and then going through the spreadsheet, because that's what you're going to have to complete is the spreadsheet. Okay, and so that's an overview of assignment 1. Okay, not a problem. Okay, guys, it is 12:02, and unless someone else has a question for me right now, I'm going to stop the recording, and then we're going to close out this session, and hopefully I'll see you guys on Thursday. I'll be back here from 3 to 5.